인공지능 기술이 빠르게 발전하면서 윤리 가이드라인이 필요하다는 이야기들도 역시나 나오고 있습니다. 오늘의 두 번째 세션의 주제는 MIT 미디어랩의 연구원이 전하는 인공지능 윤리 교육의 방법과 그리고 필요성입니다. MIT 미디어랩의 연구원인 블레이클리 페인 교수님은 이른바 Z세대를 위한 AI 교육을 연구하고 계십니다. 블레이클리 페인 님이 미국 현지에서 직접 온라인으로 강연을 해주신다고 하는데요. 인공지능 교육이 지향해야 하는 방향과 그리고 주의할 점에 대한 이야기를 함께 들어보겠습니다. 그럼 강연 함께 만나볼까요?
Hey SEF2020, my name is Blakely Hoffman Payne, calling in from Cambridge, Massachusetts in the United States. And today we're going to be talking about AI ethics education. And today I wanted to start my talk by telling you about my friend Mary Beth. So here's Mary Beth and I around 2015 when we were both in college studying computer science. I was a junior and Mary Beth was a senior, and she was getting ready to apply to full-time software engineering positions. Now, there are a few things that you should know about Mary Beth. One, she was an all-star student. She had a perfect grade point average, and she was also an excellent student leader. She was the president of our Women in Computing group, and she also had an excellent record of software engineering internship experience. She was going to be a great software engineer wherever she went. And I remember one night we were hanging out at her apartment watching a movie. And as we were watching that movie, she was sitting on her laptop, filling out contact information and uploading her resume to different job applications. And I remember one of those applications was to Twitter. And you can see that she applied to Twitter on Friday, October the 2nd at 7:48 p.m. And we kept watching the movie, and I remember I went back to my apartment later that night. And I remember going to her apartment the next day to work on some homework. And her first words to me were, "Twitter has already rejected me." It had been less than 24 hours, as you can see here. And on a Saturday, she got rejected from a job she was more than qualified for. So we were wondering, how can a student with a perfect GPA, great internship experience, lots of leadership capabilities get rejected so quickly? We had a hunch that she got rejected by a hiring algorithm. We knew an algorithm would scan her resume and probably the rest of her application as well. And although we weren't sure, we figured that perhaps the algorithm that Twitter was using to look at her resume wasn't used to seeing resumes like hers. We thought most of the people who work at Twitter have not graduated from the University of South Carolina, which would have been a keyword on her resume. And we thought, given the gender imbalance in tech, most people at Twitter probably were not president of their Women in Computing organization. Maybe these things, which were ostensibly good, were just not common at Twitter. And so the algorithm didn't know to see them as good. Now, keep in mind that this was 2015. So while there had been decades of research and scholarship already about how algorithms could be biased and perpetuate societal bias, there wasn't a ton of reporting that you see today. It wasn't common in headlines and in the news, and it certainly wasn't taught in our computer science classes at the time. So a few weeks later, Mary Beth and I attend a big tech convention. And at the convention, we are in a big ballroom, and there are a ton of company booths, and they're recruiting new engineers for jobs and internships and all sorts of cool opportunities. And I remember Mary Beth turned to me and she just said, "You know what? I'm going to go talk to a recruiter and see if they will take my resume and see if I can get an interview." And that's exactly what happened. She handed a human being her resume, and they gave her an interview. And then several months later, she accepted a job at Google. See, it's stories like Mary Beth's that make me think not only do we need AI education, but we also need AI ethics education. When I think about the developers who built the algorithm that rejected her, I think that they were probably trying to answer a technical question. They were trying to answer the question, how do we build an algorithm which flags successful candidates? They weren't really interested in the ethics question. I'm not even sure that they knew there was an ethics question. They didn't answer the question, how do we build an algorithm which equitably flags successful candidates? And I certainly don't think that they were interested in the bigger ethics question, which is, should we have an algorithm fulfill this task in the first place? Ultimately, all technical questions have an ethics question embedded in them. If you're asking, how can we build something? You should probably be asking, how can we build it fairly? Or should we be building it? But I also think that these questions of ethics aren't just for the makers of technology. They're also for the users of technology. When I think back on Mary Beth's story, I think she had two advantages that most people don't have. One, she knew that an algorithm was being used. Most people don't realize that an algorithm is going to see their resume or going to decide whether or not they can get a loan. But Mary Beth did in this case. And the second thing that Mary Beth knew, because she was a builder of technology, is that the technology could fail. It could be wrong. And she knew to go and correct what it had done. Kathy O'Neill, who's a mathematician and author of the book Weapons of Math Destruction, has said the following: algorithms are opinions embedded in code. And I love this quote because it's true. And I think that it's especially true in Mary Beth's circumstance. At the end of the day, Mary Beth decided that her own opinion of herself was more important than the opinion this algorithm had of her. And I think we should talk about how this is a really hard thing to do. AI is often marketed to us as being the product of fancy mathematics or statistics, or we're told that AI is made by geniuses, or that it's seen so much data we could never have comparable insight. And this is not only the way we market AI to adults who might purchase it, it's also how we market it to kids who interact with it. I want to tell you about a study that my colleagues at the MIT Media Lab did in 2017. In this study, my colleagues brought in kids aged 3 through 10 to play with voice agents. So imagine Amazon Alexa or Google Home. At the end of the study, they asked children a question. They asked them, do you think this voice agent is less smart than you, just as smart as you, or smarter than you? And the results that they found were really interesting. See, the 3 and the 4-year-olds, for the most part, thought that they were smarter than the voice agent or AI. But something really interesting happened with the older children. 100% of them, all of them, said that these devices were smarter than them. And this worries me. It worries me that these kids put so much authority in these devices. It worries me too that in my own research, these devices are often what children equate with AI. If you ask a student who's never had any formal AI education what AI is, they will usually tell you it's a voice agent where you ask a question and get an answer. And so kids realize that these devices are trying to ask the AI question, the technical question. They know that these devices are trying to give them the most relevant result or answer to their question. But what I don't think kids always have is knowledge of the ethics question, knowing that at the same time that these devices are searching for an answer for them, that they're making an opinion about what the best answer is, and that that opinion can be wrong. So take, for example, the following question. Who discovered America? When I was in school, I learned that Christopher Columbus discovered America in 1492. That was wrong. That's not what happened. In fact, Christopher Columbus wasn't even the first European to visit America. The Vikings had done it centuries prior. But then there's this whole thing about he didn't really even discover America at all. That is a poor framing. Indigenous people already lived on American lands long before the Europeans visited. America wasn't discovered. And so a child might ask a voice agent this question, and they might get a response that's powered by AI. But the response that they're getting is not a fact. It's an opinion about what the best answer to their question is. And it's shielded as if it's a fact because the device that's producing it is AI. Once you start to think about it, you start seeing the opinions of AI everywhere. Take, for example, the study by University of Washington researchers on Google image search results. They asked the following question. When I type in the term CEO into the search bar, what kind of images come back? Well, this is what they saw. Predominantly men, predominantly white men. In fact, the first female CEO to show up in the image results was Barbie. not even a real woman, a toy. You can look at these search results as Google's opinion about what a CEO looks like or who a CEO can be. There was a significant amount of backlash after this result was published. And so if you look at CEO nowadays, it kind of seems like it's fixed. There's a greater diversity of the people who are reflected in these search results, but there are still problems that leak through. We can see in this story that Google kind of corrected the opinion its algorithm was putting out into the world based off of public feedback. But even if you do searches like this, the one that I did for chef today, you can still see that these algorithms maintain opinions that are reflective of the imbalances and inequities in society. Chefs are still predominantly male, and we see that reflected in these search results. And we have to consider, is this the opinion of the algorithm that we want? And which stakeholders does this opinion empower or disempower? The same with the question of Christopher Columbus. Whose story we tell matters. And it's not just voice agents and search engines that are putting opinions out into the world. It's also recommendation algorithms like the one you find on YouTube. See, in 2018, researcher Zeynep Tufekci wrote the following New York Times opinion piece entitled YouTube, the Great Radicalizer. And her argument in this piece is that the recommendation algorithm found on YouTube, in conjunction with the autoplay feature, so the feature that automatically has a video start after your older one ended, were radicalizing the ideology of YouTube users. Her theory was later supported by some Wall Street Journal reporting, where journalists found that even if you came to YouTube with no previous watch history, no history at all, and started watching fairly innocuous videos, eventually the recommendation algorithm would push you towards extremist and conspiratorial content. It wasn't that this content was the most relevant to what viewers wanted to watch, but what they hypothesized is that these kinds of videos with extreme content sparked outrage in viewers and led to them staying on the platform for long periods of time, which ultimately led to more profit for YouTube and for advertisers. Story after story supports this theory. The New York Times recently reported on a young man named Caleb Kane, who credits the YouTube algorithm with pushing him towards extremist and increasingly conservative content. There's also the story about the election in Brazil that's credited to YouTube, pushing many Brazilians towards increasingly conspiratorial content about their government. It's clear that this algorithm on one of the most popular platforms for children has an opinion about what kind of content it suggests to viewers to see next. And I don't think it's necessarily true that that opinion is that it should be content those viewers would enjoy watching. The opinion is to make as much money as possible. And in a world where we know that kids are getting increasingly more information, news, and facts from social media platforms, including YouTube, I think that this is worrisome. I think that this means we have to start teaching our kids about how opinions can get embedded in technology, and particularly AI. So for the past 2 years, it's been my mission while at MIT to understand how we can teach kids about AI and ethics, and specifically how we can teach them to see algorithms as opinions and give them tools so that they can be conscientious consumers and ethical designers of AI. I think it's important for kids to start off as conscientious consumers of AI, given the fact that they live in AI-mediated worlds. When they go to find information on the internet and it's through an AI algorithm, they need to understand where those algorithms can fail and where they work really well so that they can use them to the best of their ability. But I don't think it's enough for them to simply be conscientious consumers of AI. It's also important for them to be ethical designers of AI for 2 reasons. One, because the kids of today are going to be the AI designers of tomorrow, and they're going to need these tools, both in their careers, but so that they can uphold society as a whole and make it the best that it can be. Another reason they need to be ethical designers of AI has nothing to do with their job prospects at all. It's because AI is going to become increasingly more pervasive in society, and they need to understand through tools how that AI can be changed. They need to know, as citizens of societies that use lots of AI technology, how others might go about changing and altering AI. To meet these 2 goals, I spent my time at MIT developing a curriculum on AI and ethics, primarily targeted at middle school students, so ages 10 to 14. And I like working with this age group for a couple of reasons. One, they generally have a lot of technological independence. At this point in time, they're getting their first social media account, their first cell phone. They're exploring the internet in new ways like they haven't before. The other reason I like working with this age group is because they tend to have greater moral reasoning abilities. Things are not all about the rules to them anymore. It's not just about being a good girl or a good boy. They can question whether or not rules are fair. They can think about reciprocity and if they should treat their friends the way that their friends are treating them. This makes it a great age group to talk about these kinds of issues with technology. In total, I've probably taught over 200 students during my time at MIT. But this curriculum has been expanded worldwide. It exists in several different languages and has generously been translated into Korean for all of you to use as soon as you may want. You can find all of the resources at this link. So if the goal is to have children be conscientious consumers of technology, where do we start? Well, in my curriculum, we start with a pretty simple activity where students are asked to write an algorithm for a peanut butter and jelly sandwich, a common American lunch food. Students start by specifying the ingredients for their sandwich, usually 2 pieces of white bread, peanut butter, and grape jelly, but sometimes you get a variation. And then they write specific instructions, just like you would see in a computer algorithm, to modify those ingredients to get the specified output, the sandwich. Now, the trick here is that students can't just write any old algorithm. They have to write an algorithm that makes the best sandwich. And what most students optimize for is the most delicious sandwich. So you see students add in chocolate spread or change out the grape jelly or get rid of the white bread for something sweeter. But once they're done writing their instructions for the sandwich, we, as a class, discuss what does it mean to make the best sandwich? Is the best sandwich the most delicious one? Or is it the most nutritious or healthy sandwich? Is it the quickest one to make? Is it the cheapest one? Suddenly it becomes very clear that our algorithms do in fact bake in our own opinions about the world. What does it mean for everyone in the class to have a very similar algorithm? Why might they be different? Often I have at least 1 or 2 students who have a peanut allergy and talk about how the average algorithm discussed in the class doesn't work for them. So together, students realize that maybe best can mean a lot of different things in the same way that the most relevant search results could mean a lot of different things. But we're left with a problem, right? What should our algorithm optimize for? That's where the ethical matrix comes in. The ethical matrix is a table that allows us to map stakeholders and their values for a particular algorithm. So here's an example of an ethical matrix for the student's peanut butter and jelly algorithm. You can see in this ethical matrix that there are various stakeholders for a peanut butter and jelly sandwich algorithm. There's a child who might have to eat the sandwich, and then a parent and a doctor. And they each have varying interests in the output of the algorithm. The child might be interested in taste, while the parent and doctor are interested in nutrition or cost. And what the ethical matrix allows us to do is to visualize where different stakeholders have values that overlap or where they might have values that conflict. The ethical matrix, however, isn't meant to be prescriptive. Students shouldn't just decide, oh, well, this value has the most number of stakeholders attached to it, therefore that's what our algorithm should optimize for. Rather, it's supposed to be a conversation starter to get students to recognize that many different stakeholders might have different views and be affected differently by the same algorithm. And it's with stakeholders in mind that we move on to our first AI-centered activity in the curriculum. Now, in this activity, students learn a very simple definition of AI, that it's actually rooted in supervised machine learning. They learn that AI is a data set that's fed into a learning algorithm, and the learning algorithm then makes a prediction. I like framing AI this way because it's relatively intuitive, and even though it's not all-encompassing, I like emphasizing that the output of an AI system is a prediction. Because predictions can be good or bad. They can be more right or less right. They're not facts. As a class, students think of where AI might exist in their everyday life and what data sets and predictions those algorithms use or are trying to make. For example, many of my students already use email, and so we talk about a spam filter. What kind of data set does a spam filter use to predict which emails are spam? Students often think about music recommenders, how those systems might use songs that they've listened to in the past to predict songs they might like to listen to in the future. One important example of AI that we discuss as a class is facial recognition. Where is facial recognition used in their everyday life? Usually students can say, I use facial recognition to unlock my phone, or I use facial recognition when I apply a filter to an image or to Snapchat. We talk about the kinds of predictions that facial recognition make. First, they predict whether or not a face is in an image at all, and then they predict where the face is in the image. With these predictions in mind, we then discuss where might these facial recognition systems be getting the data sets that they use to learn from. We talk about how some of these data sets come from mugshot databases used by the police or even companies like Facebook. Students then have the opportunity to build their own facial recognition model using a tool from Google called Teachable Machines. And you can see an example of Teachable Machines on this slide. Using their computer's webcam, students can take images of themselves and train a model using Google's Teachable Machines. And then their model can detect whether or not a face is in the image or not as they move. After students have this opportunity to explore Google's Teachable Machines, we ask students to build a cat and dog image classifier. We give all of the students in the class different images of cats and dogs, and using these images, we ask them to train a model that can tell the difference between the animals. But there's a twist here. So unknowingly to students, the data set that we give them is biased towards cats. We give them way more images of cats than dogs, and the images of cats are much more diverse than dogs. So when students go to test the models that they've trained, they find that it works really well for the cats and not great for the dogs. After students test their models, we give them the opportunity to re-curate their data set, make the representation between cats and dogs more equitable, make both groups very diverse, and they find that their models become much more robust and fair between both cats and dogs. This activity is great because it allows students to see how the technical underpinnings of an AI system can lead to a phenomenon called algorithmic bias. Students didn't want their models to work better on cats than dogs, but it did because of the data set that they were using. We then relate what students learned in this activity to the work of my colleague, Joy Bolomwini. In Joy's work, she shows that many commercial facial recognition systems, such as those made by IBM or Microsoft, often fail to classify faces from darker-skinned women, while they almost work perfectly in classifying the faces of lighter-skinned men. Why does this happen? For the same reason that my students found when they were building their own cat-dog image classifiers. The data sets that these facial recognition systems use are often biased toward lighter-skinned men and often don't include many faces of darker-skinned women. As a class, we then have a discussion. How could Microsoft, IBM, Facebook+, and others improve their facial recognition models? Students know the answer. They have to improve their data sets. They have to make sure that they're more diverse and representative of the people or the stakeholders that would be using the technology. Just like with the hiring algorithm that threw out Mary Beth's application, we talk about how the developers who made these facial recognition systems were probably only considering the technical question. How do we build a facial recognition system that works well for one particular stakeholder, not all of them? But they certainly weren't asking the bigger ethical question, which is, should we be building this technology at all? This is the question that I ask my students. Students know that many applications they use, such as their phones or social media, use facial recognition technology. But there's a question, should police be able to use facial recognition technology? But the question isn't just, should the police be able to use facial recognition technology? The question is, should the police be able to use facial recognition technology given the fact that we know It doesn't work on the majority of the people it's used on. It doesn't work for most of the stakeholders involved. I have my students discuss this, and usually the conversation leans towards, no, it's not fair. And this echoes many of the calls that we're seeing in the United States and around the world right now to ban facial recognition technology as used by the police. At this point in time, students now have a few tools in their toolbox when thinking about AI and ethics. They know that all algorithms, artificial intelligence or not, embed opinions into their code. They understand that data affects the predictions that AI can make, and they understand how to use an ethical matrix in order to consider all of the different stakeholders and values that an algorithm could serve. So the capstone activity in this curriculum is something that puts all of this together. We ask students to consider the YouTube recommendation algorithm. We know from research that YouTube is one of the most popular technologies that children use. They're experts in it. And we ask them, using the tools that you have in your toolbox now, design an ethical matrix around the YouTube recommendation system and reimagine what this platform might look like with all of those stakeholders in mind. At the beginning of this activity, I always ask my students, what do you think the current goal of the YouTube recommendation algorithm is? And usually the first answer I get out of any of my students is entertainment. The whole point of the recommendation system is to entertain us and show us videos that we like. But usually if I pause for a second and let students think, I get one hand up in the classroom that says, I don't think it's really about entertaining us. I think it's about selling us ads. Students go into this project as YouTube experts. They know that the algorithm works for YouTube and works for advertisers. And they're also able to recognize the ways in which these algorithms often fail stakeholders like creators or viewers. So given the opportunity to reimagine the entire system, this is what they produced. This is a group of students that decided to optimize for a more age-appropriate YouTube experience. You can see from their paperwork that they decided their stakeholders would be YouTube the company, parents, children, and YouTube creators or content creators. And they were concerned about the following values: it being educational, entertaining, profit, and then of course age appropriate. As you can see here, they say, we decided that it would be age appropriate because this would let parents, let children watch the platform longer, but that would also make more money for YouTube and content creators. In this scenario, they found a value where everyone wins. And you can see too that they're using their knowledge of data sets to make this goal happen. They say, in order for us to make our algorithm optimize for age appropriateness, we would have to teach it what age appropriate and age inappropriate videos look like. And while this might be a little bit vague, it definitely shows that they're grasping the concept that these algorithms learn from past pieces of data. From here, students are allowed to get creative. Here you can see a paper prototype for age appropriate YouTube. Students are given lots of craft materials to design what these interfaces might look like to represent the new change to their algorithm. You can see in their projects that one group decided that their interface would reflect the goal of their algorithm by flagging inappropriate videos. You can see that this other group decided that they would separate content by its age appropriateness. These are two different ways to get at the same goal, the same kind of algorithm. Instead of the YouTube recommendation algorithm, this group tried to reimagine the comments section. They were optimizing for the most polite experience. You can see here that they flagged any comments that might be considered rude and gave users options to decide how rude or polite they'd like their comment section to be. Finally, this is perhaps my favorite student project that got produced. These students decided that YouTube was indeed too addictive, and they decided to optimize for a less addictive experience. You can see here that they have an algorithm that they call the cringe algorithm. And as a user continues to watch videos on YouTube, it might start by getting very pleasant videos, like videos of dogs. But then eventually the videos get less and less bearable to watch. So you might get a video recommended to you, nails on a chalkboard, or someone picking their nose. And when you get these cringy videos, that's your cue. Get off the platform. It's been too long. My students' work make me really hopeful about the future of AI. They've creatively approached various AI problems and recognized that problems of AI, problems of code, are also problems of people and politics and how we value each other. And even if all of my students don't grow up to become professional computer scientists, I know that they will still be informed and conscientious consumers of the technology. When they use an AI system, they will know that it's an opinion, that the information that they're getting is fallible and changeable by different organizations and stakeholders. This ultimately means that they'll be able to navigate this AI-mediated world that we live in. They'll be able to take the information and use it in the best way possible for whatever situation they're in. At the beginning of this talk, I asked the following question. How can we give our students the same advantages that Mary Beth had? How can we encourage our students to become conscientious consumers and ethical designers of artificial intelligence? I argue that all of the tools in this curriculum allow them to do that, to see algorithms as opinions, understand the influence of data sets on phenomena like algorithmic bias, and using tools like the ethical matrix to consider all stakeholders who might be affected by a system in the many ways that it manifests. Now, I'd like to end with one more story. So during that first activity I mentioned, where all of the students were asked to design an algorithm to make the best peanut butter and jelly sandwich, I had a student who asked a question during the activity. I remember walking over to his table and leaning in to hear what his question was. And he looked up at me and he asked the following question. He said, "We're supposed to make the best peanut butter and jelly sandwich. So can my algorithm be my opinion?" The answer, of course, is yes. And I hope that you'll discuss how algorithms can be opinions in your communities and classrooms. Thank you. Hey, SEF2020, Blakely from slightly in the future here to answer some of your questions about my AI and ethics curriculum and AI ethics education in general. So the first question I have here are, who are AI natives? What is so unique about them? So the phrase AI natives is a spinoff of a previous phrase, digital natives, that was coined around the 80s to describe children who were growing up alongside technology and were participating in a lot of informal technology education before they ever got to school. And so we like to draw the comparison between children of today, calling them AI natives, to the children of the 80s and the 90s who were growing up with computers and video games and all sorts of technology. What is so unique about AI natives is that they have always lived in an AI-mediated, AI-curated world. So the second question we have here is, what inspired you to focus on teaching AI ethics to them, to AI natives, to children? And I think the answer to this question is a culmination of a couple of things. The first of which is a push to teach kids about artificial intelligence in general. And in combination with that, just headline after headline after headline and news story about how AI could be biased or how AI was being used to surveil certain populations in different countries, or how AI was harming marginalized communities. And, the thought going through my head, if we're teaching kids how to build this stuff, we really need to be teaching them how it could go wrong, how they can prevent this technology from perpetuating harm, but also give them the tools so that they can imagine a world that isn't dystopic. I think that something a lot of technologists are going through right now is, I have this power to code something, I have this power to build something that will scale. That is a huge power to have. I like to reference Spider-Man here, with great power comes great responsibility. So if we're going to have these curricula that teach kids how to have great power, we also have to teach them about how to be responsible with that power. So the next two questions I want to answer together. So they are, why is the ethics of AI required for us to learn? And what would the problem be of not learning about AI ethics? Now, why is the ethics of AI required to learn? I think this goes back to the two main goals I mentioned in my talk. One, we want kids to be conscientious consumers of AI, and two, we want them to be ethical designers of AI. And so building on the conscientious consumer piece, I think Mary Beth's story is a really great example of why it's important for kids and everyone in general to have in the back of their mind that there are these ethical questions surrounding AI, because we live in a world where AI makes a lot of decisions about us, and we need to realize that AI can be wrong, and it can be wrong in a way where technically it is doing what it's supposed to be doing. For example, in Mary Beth's case, that was flagging particular resumes to see which candidates would get interviews or not for a particular job. But just because it's achieving what it was technically built to achieve doesn't mean that it's working the way that we want it to. It's working as intended. And those are ethical choices because they involve how we treat other people. They involve who we give power to. And so in Mary Beth's example, she knew that this algorithm could be wrong about her resume, about her potential to be a great employee. And so I think when we start talking about the ethics of AI and we start talking about how these algorithms can affect different people in different ways, it's kind of giving some of us our power back, those of us who don't create AI, so that we can know when to kind of challenge these systems, or when we can ask for a clarification, or we can ask for a human to perhaps intervene instead of an algorithm. I think it's important for us to learn about the ethics of AI so that we as consumers have a bit more power over these technologies than we might have had otherwise. Now, to the point of being ethical designers, I think it's important that we teach up-and-coming technologists, people who might be product managers, software engineers, etc., even marketing people who market AI systems, to think about the consequences of what they are building. And, a common question that I get asked is, well, if we have an AI system that is biased, what if it's less biased than a human who would have been performing that job? So take, again, for example, Mary Beth's case. What if the person who might have looked over her resume had been biased against women, or biased against people from the South, or biased against people from my particular university? Isn't the algorithm a good thing to have in that case? And the answer here is just, well, maybe it would have been better. But the thing that is different about having an algorithm that is biased as opposed to a person who is biased is that algorithms can scale really easily. So a company who develops an algorithm to judge resumes or to flag potential candidates for a job, that algorithm is going to be made by one particular company and sold to companies all over the world. And so it's really easy for the negative impact that algorithm has to scale widely and rapidly in a way that if you have a human who is biased, it can't. That person might move from one company to another, but the kind of harm that they might do is mitigated. It's closed in. And so I would argue that it's important for future technologists to be knowledgeable in ethics, to be trained in protocols to prevent harm from being done, because the potential for harm, the potential for something to go wrong with an algorithm can scale really rapidly. There's a big cost to them not knowing about ethics. And to follow up on that point, I don't think it's just technologists who should be learning about ethical design practices, who should be doing these ethical matrices. I think it's also important for us as citizens of our community, citizens of the world, to understand the processes and protocols that algorithms could undergo to better serve us all more equitably, more fairly. And a really good example of that is recently in my hometown, so in Cambridge, Massachusetts, where I live. Recently, our city council passed a ban on facial recognition technology as used by the police, because there's all of this research, like I said, that shows that facial recognition technology is most often used on brown and Black people, and those are the communities that the technology works the least well on. And I don't think it's a coincidence that we were able to ban that technology in Cambridge. If you look at the other places where facial recognition has been banned in the United States, it's places like Cambridge or our neighboring town, Somerville, Massachusetts, places like San Francisco and Oakland. These are all kind of tech hubs. People with lots of technology expertise live in these areas and know about the harm that these technologies can do. And so what's kind of nice about teaching everyone about tools like the ethical matrix or engaging everyone in education on ethical design, what we allow them to do is to participate in the conversations at their local community, city government level, and have a say and an influence on the kind of AI that is allowed in their communities. So I think there's a lot of focus on, well, we should be teaching the future technologists how to not make problematic technology, or we should be teaching the software engineers how to build ethical tech. But I think, when we're talking about teaching kids, A, we don't know who is going to grow up and become a technologist, but B, to the question of what problem might we face if we don't teach everyone about the ethics of technology. That means that essentially we are limiting the discussion of what is ethical tech to only the technologists. And so we are having a small fraction of the world, I think it's 10% or something, build technology for the other 90%. And what we want AI ethics education to do is to give, again, some of that power back through education, through knowledge, to the people who are affected by AI. So the next question I have here is, how many hours of ethical education do you think is appropriate for 100 hours of AI education? And I appreciate this question. I understand where these kinds of questions come from, because if you're an educator, you only have so much time in your day to focus on AI-specific curricula, education, activities. So I think it's a very reasonable thing to ask, how much time should I be spending on this topic relative to another topic? That being said, I don't love the framing of this question, and here's why. I think there is a real danger that if we say you're supposed to study AI for 100 hours, and we say that 25 of those hours should be focused on ethics, that feels a little bit to me like a checkbox approach to ethics. And so what I worry about is you go into this and say, I'm going to teach 75 hours of AI and 25 hours of ethics, and that'll be sufficient. But the thing that happens here is that mindset of, oh, I only have to check off a small section of my time to be about ethics. That mindset gets passed on to our children. And there is a lot of research to indicate that when we approach ethics education this way as a separate entity from our technical education, that kids and students in college and higher ed learn ethics to either be a specialty, so something that someone else who only does ethics will focus on, so it's not their concern, or they learn it to be like an afterthought or something that they just have to kind of do once and then they forget about it, and it doesn't become an ongoing conversation. So a problem that we see in college AI ethics or college tech ethics is that often the ethics bit is relegated to being one class, one course that you kind of take sometime at the end of your college program. And this teaches through practice, by example, to those students that ethics is just kind of something that you can wait for the end, leave off till the end in their day-to-day projects. So this is what I want to avoid. I don't want us to say we're going to do 100 hours of AI education and 25 hours of that could be ethics education. And I don't want to say that because I don't want us to be unconsciously teaching our students that they only have to spend a quarter of their time thinking about ethics. You could imagine a scenario where you spend 25 hours on ethics and 25 hours doesn't get you to the kinds of conversations that you want to be having on the subject. Similarly, you can imagine getting to 15 hours of ethics education and feeling like you in your classroom are very settled and know where to go with the content or feel very educated on the matter. So I hesitate to put a rule on this. What I will suggest is that anytime you are going to teach about AI, that you have some ethics piece situated with that lesson. So if you're going to be talking about supervised machine learning, like I do in my curriculum, have a conversation about algorithmic bias, have a conversation about how data sets are curated. If you're going to be talking about recommender systems and thinking about metrics like engagement, have serious conversations about how you measure engagement. What factors do you measure? What do you learn from? And are the things that you're measuring actual indicators of the thing that you're trying to achieve? As kind of a guide for best practices, I think it's important to, anytime you're teaching about AI, start with a conversation around ethics, around politics of AI. Perhaps that means doing one of these activities. Perhaps that means discussing current events or current legislation or policy that is up for discussion, and then move into the technical curriculum and end with another conversation around ethics. I think the best version of this is that you start with ethics, you do a little bit of technical content, you do a little bit more ethics, and then you iterate so that the ethical design process gets embedded with the technical design process, and children can learn that this is just how things are done and that we always embed ethics as we're designing things. So just to kind of recap, I don't want to put a number of hours on how much time you should be spending on ethics, but I think that if you are teaching AI at all, you need to be asking the question, where are we having conversations about ethics? When are we having conversations about who this technology hurts, who this technology helps? When are we having conversations about policy? When are we having conversations about how this technology could make us feel? I think that you just kind of have to use your best judgment, but make sure that no matter when you are teaching something technical, there is always something ethical associated with it. Your curriculum is well known and applied in Korea's AI education system. What would be the best way to utilize your source? So let me just say that this makes me so happy to hear. I'm so glad that people are using the curriculum and finding it helpful. And there are a couple of ways that I think that you can best use it. So first, I want to say that the curriculum was designed to be very flexible. So you can use it in the traditional classroom setting. You can use it in a summer camp or workshop format. I can even imagine you doing it at home as a family with your children. In particular, it was designed to be very flexible in the traditional classroom. So you could imagine using some of these activities in a computer science or technology-focused classroom. But I also want to push that a little bit. I think that you could also use the curriculum in other subject areas. For example, you could imagine using the algorithmic bias activity with Google's Teachable Machines as a way to teach the scientific method. You can have students register hypotheses. You can have them do an experiment to see what the output of their models are. Are they biased? Are they fair? And you can have them repeat their experiment and see if they get different results when they change different variables, their data set, and come up with conclusions. Another activity that is in the curriculum that I didn't present on, but is there, is an activity where I have children interact with a variety of technologies. For example, emotion recognition technology or GANs, so AI that helps you make art. We have them interact with these various technologies and then consider what is the best case scenario and what is the worst case scenario. And I can imagine this activity being modified and turned into a creative writing exercise. And I can imagine it being used in the language classroom. So I think that there's some flexibility, and I would encourage educators to find what works best for them. What might work in my classroom isn't going to work in your classroom, and that's totally okay. To that, I would also add, feel free to remix or reimagine some of the activities. If your students are not gung-ho about YouTube, do a different platform, do Instagram or another social media platform. If they are not interested in making peanut butter and jelly sandwiches, pick a different food object for them to write an algorithm for. I think feeling free to mix it up, find what's best for you, find what works for you. That is the best way that you can use this resource. And finally, I would just add that ethics is ambiguous. When you go in to have conversations about how to remedy algorithmic bias or how to use the ethical matrix, I think it's important to set expectations for your students that these are not questions with definitive right and wrong answers. And sometimes that can be a really uncomfortable thing to sit with. So I think it's important to set the tone from the beginning of any activity that you're doing, that you're going to have a discussion, that there are no right and wrong answers. But I think it's also important to make the classroom feel inclusive, feel safe for children to voice their ideas, voice differing opinions, and set a tone that while we may disagree, we all fundamentally agree on the value of other humans, the value of other human life, regardless of our differences. So I think expect that going in when you teach on these subjects. Question 8, is there any ethical education we can try out at home? So yes, I think that you can use a lot of the activities I already described at home. And I always think that if you have an older sibling, teach a younger sibling, or have children teach parents, I always think that is a great exercise to do. The next question I have is, are there any cases where we can face ethical problems of AI in our daily life? So I think this is a really good question. I want to add here, though, that this question of what can we do as consumers of technology about the ethics of AI, I think it's a good question. I think that, as you know, in general, people need to be more educated on AI, particularly the fact that there are ethical questions associated with it. Because, like I said before, knowing that there are ethics questions associated with it gives us as consumers some of the power back. But really, as individual consumers, we have very little power relative to the tech companies that build these systems. And so while I appreciate the question of what should I as an individual be doing to contribute to the betterment of this technology in the future, I also think that we need to be asking this question to tech companies who build AI systems. And we should figure out systems of accountability so that if they build something and it is harmful, they mitigate that harm and they repair that harm. And lastly, any word you want to share with Korean students and teachers? Well, first, I just want to say thank you so much for being so supportive, and I'm so glad that you all are finding this curriculum useful. I would encourage you to remix it, make it your own, play with it, and definitely share with me what you change about it, what worked, what doesn't work. I always love getting emails with pictures of students or adults using this activity to further their knowledge about AI ethics. I'd also like to add that I hope that all of you are doing okay as well as you can be during this unprecedented time that we all live in. I hope that each of you are safe and healthy and that your friends and family are safe and healthy. And as many of you probably are aware, there are several protests going on in the United States, but also around the world in the wake of the killing of George Floyd by the police. And I just want to say that we cannot achieve racial justice until we achieve tech justice. And if you're interested in my talk, if you're interested in the Black Lives Matter movement, I would encourage you to visit the Algorithmic Justice League website online and to look more into the work of my colleague Joy Buolamwini and her work on facial recognition. Again, if AI doesn't work for someone, it doesn't work for everyone. Thank you so much for having me. It's been a pleasure to talk about my work, and do let me know how you use the curriculum, what you learned, what you changed and improved. I look forward to continuing the conversation. Thanks.
인공지능 교육이 지향해야 할 점, 이런 점들이 어디인지 되새길 수 있는 소중한 시간이었습니다. 이런 발표를 도와주신 블레이클리 페인님 정말 감사드립니다.